Hey guys, sorry I'm not there with you today. Before we get started and give the full lesson, I just wanted to give you a calendar look of what is happening in the next couple of weeks. So the top line is this week in class. So this is you on Monday. We're going to do the discriminant today. This is you on Wednesday. You are taking an assessment. That means that your IP for today is an assessment review. So again, remember you get 3 points for completing it, and you get that 4th point for doing or completing a haiku check. And then when you get to next week, Monday, excuse me, we will start a benchmark review. Wednesday, we will have a benchmark review, and then that Friday, you will be taking a test, or sorry, you will be taking your benchmark. The benchmark will be over skills 1 through 12. Your assessment will not include skill 12 since we're just learning it today. And then we're also remediating, I'd have to go back and look, I think it's skill 6, but you'll see it on your review. So that gives you an idea of what is happening in the next couple of weeks. After benchmarks, of course, you have PSAT, and then you guys have fall break. So anyways, we can go over that again on Wednesday if you need, or if you've got some questions about what's going on. Let's see. All right, so skill 12 is using the discriminant to determine the type and number of solutions. The type we've actually talked about in our lesson, let's see, I think it was skill 10. So the type is going to be, are they real solutions or are they imaginary solutions? And then the number of solutions are going to be 0, 1, or 2 solutions. So that kind of gives you an idea of where we're headed. So after using the quadratic formula or factoring, these are the answers I got. What type of solutions are they? So number 1, when you look at those are real solutions. Number 2 would also be considered real. They would be considered irrational, but real solutions. Number 3, if you look at number 3, that's an interesting one. So if you take the square root of 0, you would just get 0. There is no such thing as plus or minus 0. So in fact, if you go to simplify number 3, you would just have -5 over 9. So number 3 would show you an example of where you would only actually get one real solution. Number 4, clearly 2 real answers. Number 5, as soon as you see those I's in the problem, I means you are going to deal with imaginary solutions. So number 5 would be an example where you have 2 imaginary solutions. And then number 6, again, you would have 2 imaginary solutions. Remember that plus and that minus is giving you 2 solutions, not just one. Okay. So that kind of gives you an idea of what your answers can look like. It gives you a little bit of a conversation of what would it look like to only have one solution, and then also imaginary versus real. So again, discriminant, how many solutions there are, but also what type of solutions. So your answers today will need to have both of those in there. Okay, look at the graph below and determine how many real solutions the quadratic equation has. When you're looking at this, you have to go back to our lesson, I don't know, from a couple weeks ago. If we are looking for the solutions on a graph, what are we actually looking for? I hope you guys are answering that question out loud. Solutions are the same as x-intercepts. Solutions are the same as x-intercepts. So on this first graph, you have an x-intercept over here, perhaps at -1.75. And then if you look over here, you have another solution over there at probably 1.75. So for this first graph, it says how many real solutions do you have? Underneath that, I want you to write 2 real solutions. There are 2 real solutions there. Okay, go to the next one. Again, solutions are the same as your x-intercepts. Here's your x-axis. Are there any x-intercepts? Is your graph crossing this x-axis? The answer is no. So how many solutions do you have? You have 0 real solutions. You might have some imaginary solutions. In fact, you probably will have 2 imaginary solutions, but you only have 0 real solutions. And then on this next one, I think it's interesting to look at right there. It only kind of bounces on that 1. So it comes down, hits the x-axis at 1, and comes back up. That is considered one solution at 1. So x equals 1 is one real solution. So again, graphically now, you have seen what it looks like to have 2 solutions, to have no solutions, and to have 1 solution, all of those being or referencing real. So 2 real solutions, no real solutions, and 1 real solution. Okay. The quadratic formula to the solution of ax squared plus bx plus c is equal to 0 is, and then you have that formula, right? We've all seen that formula. That's not new to us, okay? The idea with that is that that is considered your discriminant, that highlighted b squared minus 4ac part. That is what we call your discriminant. Discriminant is one of those things that we expect you to have memorized. It's not that hard. It's part of the quadratic formula. We will probably be giving you the quadratic formula, so you just have to know which part you use. Okay, go back in your notes a couple of a little bit. Remember when we had that 0 underneath there? That 0 then made us only have 1 answer. Okay, and so that's why that square root part is what determines how many answers we have. Also, how do you create imaginary solutions? You would have to have a negative square root. So you can see that the part underneath the square root is really determining a lot of things. So that's why that's considered the discriminant, b squared minus 4ac. So b squared minus 4ac is our discriminant, numbers and types of solution. If the discriminant is positive, in this blank you're going to write that you will have 2 real solutions. 2 real solutions. If your discriminant is 0, so if you plug it in and you get a 0, you are only going to get 1 real solution. Notice I'm giving you not only a number, but I'm also giving you a type, 1 real. If you have a negative solution, you can give 2 different answers. You can either tell me that you are going to have 0 real solutions, or you can tell me that you're going to have 2 imaginary solutions. And it's up to you how you want to label that. So positive is 2 real solutions. Negative is 1 real solution. Sorry, 0 is 1 real solution. And then negative is going to be either 0 real solutions or 2 imaginary solutions. So it says find the discriminant. Example number 1, x squared minus 15 plus 8x equals negative 6. So they ask you to put that into standard form. We've been practicing that a little bit. So in order to put that into standard form, you're going to add this 6 to the side, but you're also going to rearrange those 2 things, right? And so you're going to go ahead and have an equation that should say x squared plus 8x, right? Because you need it in standard form. And then you're going to have minus 9. X squared plus 8x minus 9. Okay, so x squared plus 8x minus 9, and then that's equal to 0. Now you're ready to go ahead and find the discriminant. D is equal to b squared minus 4ac. So D is equal to 8 squared minus 4 times 1 times negative 9. B squared, so 8 squared is 64. Negative 4 times 1 times negative 9, so you add those, that becomes a plus. So you have a 64 plus a 36. The answer then is that positive, 0, or negative? That is positive. So your discriminant is just your number. So your number is the 64 plus the 36, which is 100, excuse me. And that would tell you that you have your discriminant is telling you that you would have two real solutions. It's not telling you what the solutions are. It's just telling you what's going to happen if you were to solve it. Okay, let's go to the next one. Example number 2. X squared is equal to 7x. Obviously not acceptable, so you're going to go ahead and subtract that 7x to the other side. A is equal to 1, B is equal to -7, and then C is equal to 0. Again, for your discriminant. Discriminant is equal to B squared minus 4AC. So -7, remember, in parentheses, squared, minus 4 times A times C. So -7 squared is going to become a positive 49. When you multiply -4 times 1 times 0, it just becomes 0. So you would have a 49. 49 is positive. That tells you that you have two real solutions. All right. Number 3, find the discriminant of 6x squared minus 8 is equal to 2x minus 5x squared. Same thing, you've got to move all your pieces. So you're going to subtract 2x to this side. You're going to add 5x squared to the 6x squared. So you end up with 11x squared minus 2x minus 8 equals 0. A is equal to 11, B is equal to -2, and C is equal to -8. Again, to go ahead and do your discriminant, you're going to have B squared, so -2 squared, minus 4 times A, which is 11, times C, which is -8. So you're going to have 4, and then -4 times 11 times -8. That should be getting you 356. Again, positive, two real solutions. Use the discriminant to determine the types and numbers of solutions. What type or number of solutions? Sketch the graph of the quadratic function using the information about the solution. So again, we've been practicing this. You're going to go ahead and add 5 to the other side. So 12m squared minus 13m plus 5 is equal to 0. A is 12, B is -13, C is 5. You're plugging it in. B squared minus 4AC. Okay, plugging in your values. 169 minus 240 is equal to a -71. Because 71 is negative, that means that you have no real solutions. Going back to where we started the lesson, if you have no solutions, that means you have no x-intercepts. So it does not cross the x-axis. So that's what this picture is. This is your x-axis. This is your graph. And notice it does not cross the x-axis. Also, I want you to notice that your graph is opening up, which it should be. It's opening up because A is positive. So when you're asked to sketch the graph, you're not only thinking about how many times it's crossing the x-axis, but you're also thinking about whether it opens up or down. Example number 5. What types or number of solutions does the quadratic equation have? Again, moving the 5b to the other side, rearranging order so it's in standard form. A is equal to 4, B is equal to -8, and C is equal to +4. Plugging those values in, you would end up with a 64 minus 64, which is 0. Since your discriminant is 0, that means that you have one real solution, which means you're going to cross the x-axis once. Also looking at that, A is equal to 4, which is positive, so it should open up. So that's why we have a parabola opening up and only crossing the graph once. For the meantime, we're not going to worry about example 6. You'll be okay without that. That should be everything you need to know for discriminant. And if you need more help on the notes or you need to see them again, remember that you can go to Haiku and check over the notes again.